So I am recording, but feel free to stop me. I could always pause and re-record. We are continuing with yesterday's lesson, 8.6. Yesterday we did solving rational equations, and today we're doing solving rational inequalities. Okay, so let's move on to the worksheet that I gave you. Now this worksheet, we did several questions on the equations. So this whole front side was all nothing but equations. We did a lot of these. There's a video posted already on Google Classroom. That's video 1. On the back side, that's where we get to inequalities. So let's jump to some of these questions on the inequalities. However, I'm going to rewrite these questions in my notebook because they do require a lot of space. Let's all look at number 19. If you're going to write on the worksheet itself, you're probably going to have to write really tiny. And here's the deal. These are the steps right here to solving rational inequalities. Okay, step 1 is to solve it as if it were an equation. Like you could just put an equal sign if you wanted to and just solve it and get some answers. Okay. Step 2 is to set the denominators equal to 0 and then solve, and you're going to get more answers. Okay. So what I mean by that, you're going to go to the x plus 4, set that equal to 0, x plus 10, set that equal to 0, and then you're going to get some more answers. And step 3, plot all the answers on the number line. Plot the answer that you got to solving the original, plot the answers that you got setting the denominators equal to 0, and you have a bunch of answers that you put on a number line, and then you test the areas. And then based on the areas of where it works, those are going to be the inequalities that represent your answer. So the best way is to just dive right in. This does take a long time. Hopefully you're mentally prepared here. So step 1, solve it as if it were an equation. Okay, so let's go to this equation or this inequality and solve it like if it were an equation. You don't want the fractions, you want to get rid of the fractions. So you're going to multiply everything by the denominator of the fraction you want to get rid of. I want to get rid of the right one first by multiplying by x plus 10. Okay, so everybody go ahead and put a x plus 10 up there in parentheses. That way it cancels out with the x plus 10 down there. But then again, what you do to one side, you do to the other. So you're going to have to multiply this side by x plus 10, okay? And the problem there is, well, it's not a problem, but the reality is that this x plus 10 will not cancel with that. So you actually have to multiply the x plus 10 times the x minus 2. And that requires distributive property and combining like terms. X times x is x squared. X times negative 2 is negative 2x. And then you distribute 10 times x. That's a 10x. And 10 times negative 2 is a negative 20. And you can combine your middle terms, the negative 2x and the positive 10x. That'll give you a positive 8x. So you really have an x squared plus 8x minus 20 on this numerator spot of this first fraction because this didn't cancel. So you still have a fraction. Let me rewrite my fraction right below it. And the denominator is still x plus 4. But up on top, I have a x squared plus 8x minus 20. Okay. I did get rid of the right fraction because I multiplied by that same denominator, which cancels out. So you could put a greater than symbol, or you could just, pretend it's an equal sign. You can put an equal sign, just solve the equation. And we will have an x plus 1 right there, okay? So now let's get rid of the other fraction. The other fraction, obviously, we have to multiply both sides by x plus 4. So x plus 4 is what you're going to multiply by. That way it cancels out. No more fraction. You're going to have a x squared plus 8x minus 20. Now, what you do to one side, do to the other. So you're going to have to multiply the other side by x plus 4. So it's totally up to you if you want to multiply the whole thing by x plus 4, which is going to require you to do distributive property and combining like terms. Or you could have also instead of putting it like that, you could have also said, I'm going to multiply the x by x plus 4 and the 1 by x plus 4. It's the same exact thing. You're just multiplying everything by x plus 4. So it depends if you want to put the whole thing in parentheses and then do the distributive property and combining like terms, or you can multiply each one of them by the binomial x plus 4. So if I do that, x times x is x squared. I'm just going to write right here, x squared. X times 4 is 4x. And then I have the 1 times x, that's another 1x. And 1 times 4 is another 4. And then you combine the middle terms, 1 plus 4x is 5x. So you really have the equal sign that comes down right here, and you have the x squared plus 5x plus 4. By the way, if I make a mistake, please stop me. I don't want to record a mistake. I'll stop it and re-record it. Anyway, let's continue solving this thing. If you have x squares, it's probably better to just move them to one side. And in this case, it works out beautifully because when you subtract x squared there, it cancels out. And you subtract x squared over here, it also cancels out. So we have a nice, beautiful 8x minus 20 equals 5x plus 4. And we are solving. So let's get the x's to one side and the numbers to the other. So I'm going to move the 5x by subtracting it. And I might as well do 2 steps in one. I'm going to move the 20 by adding 20, moving it to the other side, adding 20. Does that confuse anybody? I apologize. I'm doing 2 steps in one just for the sake of space. So on the left side of my equal sign, I have the 8 take away 5, which is 3x. And on the right side, 4 plus 20 is 24. So I really have the simple equation 3x equals 24, which means that x equals 8. So divide by 3, x equals 8. Got it? That was barely step 1. Dang. Let's move on to step 2. What is step 2? It says right here, let me zoom out. Step 2, set the denominators, because there's more than one denominator, of the original question, set it equal to 0 and solve. And then we plot all of our answers on the number line. So let me just jot this down. Step number 2, we're going to set the denominators. Here's one denominator, x plus 4. I'm going to write that down. X plus 4, that equals 0. And set the other denominator, x plus 10. X plus 10, that also equals 0. And we solve both of them. So we're going to get subtracting 4, you get x equals negative 4. And then subtracting 10, x equals negative 10. That was step 2. Step 3, it says plot all answers on a number line and test areas. So here we go. Step number 3. Okay. Draw a number line. Okay. Draw a number line and plot all these answers on this number line. So obviously, let's go with the most negative number, which is negative 10. Put that on the left side. So you have negative 10 over here on the left side. Then we have negative 4. And then we have positive 8 over here. That's not completely accurate, but yeah. Negative 10, negative 4, 0 somewhere right here, and then 8. Yay? So it says plot them and then test the areas. So we're going to test the areas. What do I mean by that? Let's take a look at the left side here, and let's test a value that's on this side of the negative 10. So give me a number that's on the left side of negative 10. Negative 11. Okay, so that's what we're going to do. We're going to write down test, and let's say negative 11. So I want to put a dot right here. I want to put a negative 11 just to show you that I'm testing that side. And test negative 11, how? By plugging it in. We're going to plug it in, okay? Plug it into what? Plug it into the original. Now, the original says x minus 2 over, so I'm going to put the x minus 2, but in this case, I'm plugging in a negative 11 for x. So it says negative 11 minus 2 over, and I'm going to plug in a negative 11 again plus 4, negative 11 again plus 4, and then it's still with that greater than symbol. And over here, instead of x plus 1, I'm going to plug in a negative 11 plus 1. So it is a fraction. There's a plus 1. I'm plugging in the negative 11 over here as well. And then down here, it's over, I'm going to plug in a negative 11 again plus 10. So negative 11 plus 10. This is what I mean by testing the areas. So we are testing only the left side right now of this thing, okay? How? By plugging in any number that's on the left side of negative 10. You guys pick negative 11. That's what I'm testing. So up here, I have negative 11 minus 2. What's that? Negative 13. So I really have a negative 13 over negative 11 plus 4. What's that? Negative 7. Okay. And then a negative divided by a negative positive, all right? So we could just change that to a positive, okay? And we're saying that that fraction, 13 over 7, that's almost 14 over 7, that's almost 2. So it's like 1 point something. You could be precise with the calculator if you want, but that value should be greater than what we get on the right side if it's true. Let's find out. So on the right side, we have negative 11 plus 1, that's negative 10. And then how about negative 11 plus 10, that's negative 1. So that's really a positive 10. Okay, so let me ask you this. It's not even 14 divided by 7, so it's not even 2. So it's like 1 point something, 1 point something. Is that greater than 10? No way. 1 point something is not greater than 10. Let me be precise here. I don't want to just say 1 point something. So with the calculator, it's 1.857, but we get the idea. 1.8 is not bigger than 10. So this is false. False. It doesn't work. What does that mean? That this area over here doesn't work. So I'm going to put just a little x like that just to remind me that my inequality is not x is less than negative 10. It's not on the left side. Now I need to test an area that's between negative 10 and 4. So this is very tedious. This takes a long time. It requires a mathematical endurance from you guys. So right here, we barely tested one of the areas. Let's test another area. Let's test this area right here. Give me a number between negative 10 and negative 4. Negative 8? Sure, why not? Okay, so we're going to test, and let me write it over here on the side. Like I said, you need a lot of space for this. We're going to test negative 8. I want to use the blue color this time. How? By plug it in. I'm getting lazy about this. So test 8 by plugging it in, okay? So we're going to rewrite the whole original, but instead of the negative 11s that are right here, right there, right there, right there, I'm going to plug in a negative 8. So I'm going to start by just rewriting it. I have that with the minus 2 greater than that with the plus 1, and then plus 10 down here, and a plus 4 over here. And we are plugging in a negative 8 instead of the negative 11s. The negative 11s did not work. Let's see what happens with the negative 8s. So when we do this, up on top, negative 8 minus 2, that's negative 10. And down here, negative 8 plus 4, that's negative 4. A negative divided by a negative is a positive. 10 over 4 reduces down to 5 over 2. And everybody knows that half of $5 is $2.50. So you could leave it as 2.5. And let's see if that's greater than the other side. The other side, when you do negative 8 plus 1, that's negative 7. And negative 8 plus 10, that's 2. And negative 7 divided by 2, that's negative 3.5, half of $7, $3.50. But it is negative, and we know that any positive number is bigger than any negative number. So what do you say about this guy? This is true. True. Happy face, okay? So by us testing the negative 8, which happens to be right here between the negative 10 and the negative 4, and it worked, we now know that the negative 8, check, it worked. So this means that all the values in here work. Out here, it doesn't work. All the values in here do work. Now, we still need 2 more areas to test. No manches. It takes a long time. I apologize. So this was testing negative 8, and it did work. But now let's test a value between negative 4 and 8. What do you think is like an easy number to plug in between negative 4 and 8? 0, definitely. Let's do that. Maybe I'll go over here. Now you're just going to do this wherever you have space on your paper. So I'm going to say test. Let me plug in a 0 and go back to yellow. We're going to test 0. So I'm going to rewrite. I mean, you could go back to the original and rewrite this thing, or you could go with right here. Instead of plugging in the negative 11s, we're going to plug in the 0. So rewriting it, fraction, subtract 2, plus 4 on the bottom, greater than symbol, plus 1, fraction, plus 10. Plug in those zeros in those blank spots. And on this fraction, 0 take away 2 is negative 2. Over 0 plus 4 is 4. And negative 2/4 reduces down to negative 1/2. And then on this side, 0 plus 1 is 1, 0 plus 10 is 10, so you get 1/10. Just bring down 1/10. And this says that negative half is greater than 1/10. Is any negative number greater than any positive number? No, it's not. So this is false. False. This is no, it doesn't work, right? So when we tested the number 0 by plugging it in, 0 is over here. Might as well show that on the number line. We tested 0 and it did not work. Little red X right there. That means that none of these guys between -4 and 8 work. None of them work, okay? So far, to the left of -10 doesn't work. Between -10 and 4, it does work. Between -4 and 8, it doesn't work. Let's test over here, see if it works or it doesn't work. Give me a number that's greater than 8. 10, okay? So this was testing 0, which did not work. Now let's test 10. So I want to go back to, I want to put a blue 10 right here. I'm going to test 10. I want to write out test, the blue number 10. How? By plugging it in. I'm not going to write that out. But let's plug it in. Once again, I'm going to rewrite this, but instead of the yellow -11s, I'm going to plug in a blue 10. So once again, we have the fraction, subtraction 2, plus 4. We have the greater than symbol, fraction, plus 1, plus 10. And we're plugging in this time a 10 right here in all of those spots. So we end up with, on the first fraction, 10 take away 2, that's 8 up on top. And 10 plus 4 on the bottom is 14 on the bottom. 8/14, you could reduce that by 2. You have 4/7. And that is maybe, let's check if it's greater than, let's do the other one. 10 plus 1 is 11, and 10 plus 10 is 20. Okay, so if you visualize this, 11/20, that's just a little tiny bit more than half. And 4/7 is going to be a little bit more. So that is a true statement. But to be on the safe side, get a calculator and type in 4 divided by 7 and change it to a decimal. And you'll see that 4 divided by 7 is 0. Let me write it out, 0.571. And let's check 11 divided by 20 on a calculator, change it to a decimal. It's 0.55. So it's pretty clear that 57 cents is greater than 55 cents. So this is true. Yay. What does that mean? That this works, okay? So now we go back and we write our answer from the interpretation of this graph. So our final answer is the area between -10 and -4. So you're going to write that as a compound inequality, -10, -4, x in the middle with less than symbols. That compound inequality is saying that your x values have to be greater than -10, but the x values have to be less than -4. So it's between -10 and -4, just like all the compound inequalities we've written in the past. And there's another inequality that it does work. That would just be x is greater than 8. So you could put comma, x is greater than 8. So here's your final answer. The compound inequality, -10 is less than x is less than -4, and also x is greater than 8. Dang, that was fun. Not all of these questions are going to be this ridiculous or this long. Let's take a look at number 20. That's also on your worksheet. This is fun compared to the previous one. Okay, what do you want to get rid of? Which fraction? K. Okay, multiply by k. Multiply by k. You know what? It's probably better to go with 3k because it'll get rid of both of them at the same time. So if we go 3k and 3k, check it out. Oh yeah, don't forget, multiply the 0 times 3k, which is not going to do anything. But if you look at this fraction, cancel it with that denominator, 3k's are gone. You have a nice, beautiful -4. And over here, the k does cancel with the k, and you have 3 times 3, which is a 9. And you end up with a greater than 0 times 3k is 0. Are you with me? What does that mean? That means that there's no more k's, and if you did 9 take away 4, that's 5. 5 is greater than 0. What do you think of this? Is 5 greater than 0? Yes, 5 is greater than 0. When is 5 greater than 0? Always. What happened to the k's? They disappeared. They canceled out, right? What does that mean? That k is irrelevant. No matter what you plug in, you end up with a true statement, okay? So you could have plugged in a 1 right here and a 1 right there, and it's going to be a true statement. You could have plugged in a -5 and a -5, and it'll give you a true statement. It doesn't matter what k is. So technically, right here, you would say k equals all real numbers. Or abbreviation, this symbol, the R with the double stick. Okay, k equals all real numbers. You could have also said infinitely many solutions, right? The reality is the k's canceled out and you ended up with something that's always true. So that was a lot easier. You didn't have to do anything else for this one, okay? All real numbers. What if you would have tried solving it and the k's cancel out and you end up with something false, like 5 is less than 0? Then it wouldn't be all real numbers. What would it be? No solution, right? When it's impossible, you just say no solution, okay? All right, so we are good with that one. That one's pretty easy. Do you guys want another? Yes, please. Okay, let's do one more and that's it. Take a look at number 23. And you can do the rest. Step 1, let's solve this thing. Multiply everything by what? 2m is probably the easiest. Why? Because check it out. When you go 2m, that cancels, no more fraction. But when you go 2m right here, the m's also cancel, but you have to multiply 3 times 2. And when you multiply by 2m over here, the 2's also cancel, but you have to multiply 5 times m. So by us multiplying by that bigger, technically LCD value, it cancels out all 3 fractions. So we end up with a 1 minus 3 times 2 is 6 is less than 5 times m is m with the negative in front, negative 5m. Okay, so now let's solve this thing. What is 1 take away 6? It's negative 5. Negative 5 is less than negative 5m. Let's get m by itself. We're going to divide by negative 5, divide by negative 5. We are on our last step of an inequality. And when you divide or multiply by a negative, you have to flip that inequality symbol. So that becomes a greater than symbol. So you have 1 is greater than m. So when you flip that to get m on the left side, you get m is less than 1. I apologize. Thank you so much. And like I said, you could have put an equal sign. You'd have m equals 1. You're going to plot that on a number line anyway, and you're going to test areas. Step 2 is where you set the denominators equal to 0. So 2m equals 0 and m equals 0. They're both going to give you the same answer. 2m, if you set that equal to 0, or m equal to 0, you still get the same answer, m equals 0. So you don't get a bunch of different answers. You just have this answer and that answer. So we can now move on to step 3. Step number 3, which is plot your answers on a number line and then test the areas. So we're going to put the 0 right there, and we're going to put the 1 right there. Okay, so there's only 3 areas to test. Okay, and technically, we already know that since we kept the inequality, we didn't replace it with an equal sign. This is saying where your answers are going to be at with regards to 1. M is less than 1, less than's to the left. So I know when I test this side, it's not going to work. Okay, so I know it's either going to be here, maybe both of them, or maybe just between 0 and 1. But it's definitely not going to be over here because I already know m has to be less than 1. Anyways, let's test. Step 3 is the test. And let's pick a value on the left side of 0. Give me a number to plug in over here. Which one do you think is easy to plug in? Negative 37? No, I'm just kidding. Negative 1, yeah, for sure. So we're going to plug in a negative 1 right there. And again, how do you test that? You simply rewrite the original, but instead of m's, you plug in the negative 1. So I'm just going to rewrite it. First, I'm going to write test negative 1. And let me show my work. 1 over 2m, I'm going to leave a blank spot, minus 3 over m, leave a blank spot, is less than negative 5 halves. So I'm going to plug in a negative 1 right there, and it is multiplication of negative 1, and a negative 1 down there. So this is pretty easy. When I do this, 2 times negative 1 is negative 2. That becomes a negative half. By the way, you could do this on the calculator as well. If you think about 3 divided by -1, that's -3, but with the minus sign, minus -3, that's a +3. And that should be less than -5/2, which if you take $5 divided by 2 is $2.50, so -2.50. So what is half a dollar plus $3? $2.50, and it is positive. And of course, you could do this with a calculator. Type that into a calculator, and you'll get 2.5. Is that less than -2.5? Heck no, because a positive is always greater than a negative. So this right here is false. So that tells you that this does not work. I'm just going to put a little red X right next to that -1. That's telling me that this area doesn't work. Let me test the value that's between 0 and 1. Give me a number between 0 and 1. 0.5, or as 1/2, right? You could say that. Let's test right there perfectly in the middle. That would be the value 1/2. So when you test it, we already tested -1. Now let me test -1/2. Or you could test it with the decimal, 0.5, -0.5. Wait a minute, not -0.5, positive 0.5. Why did I put a negative right there? I'm losing it. So testing 1/2, rewriting everything, 1/2 times 1/2, and then -3 over 1/2, and then is less than -5/2. Okay. So when you multiply 2 times half, that just becomes 1. And of course, 1/1 is 1. And then minus, and think about this, 3 divided by half, that's really 3 times the reciprocal of half, which is 2. And of course, you could do this on the calculator. 3 times 2 is 6. So you really have a -6. And it's less than -5/2. That's 2.5 as a negative. So the question is -5 less than -2.5? And the answer is yes. This does work. That's true. -5 is definitely smaller than -5/2, which is -2.5. So this guy over here, check, it works. So this is where your answers are at, between these two. And if you were to test a value like 2, it's not going to work. How am I concluding that already? Because we actually kept the inequality symbol, so I know my m's have to be less than 1. So if I test something over here, I know it's not going to work. So the only area that works is the area between 0 and 1. Okay? So what's my final answer going to be? Yep, the compound inequality, 0 is less than x is less than 1. There's my final answer. And I'm going to stop right there because there's not that many questions left, and you guys could work on those other ones.